Hey everybody, this is Larry. This is the 10th day of the Leetcode daily challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. My AC is still working in case you're curious and wondering, but I did figure I put on the t-shirt. Even though it's still, okay. It's only 77 degrees outside today, but it's still pretty warm inside. Anyway, okay. So I usually start these live, so if it's a little bit slow, fast forward or watch another video or whatever you need to do. I believe in you. Okay, today's problem is my calendar 1. I feel like this is like one of those movies that they're very ambitious and they you don't even know if it's going to be a good problem, but they already have like 3 sequels coming. What are you doing? Just like, make sure it's good first. Anyway, implement a My Calendar class to store your events and your event, and can be added if added event cannot cause a double booking. Okay, so you have an open interval. So it's a real number. Is it real? It seems like these are all ints, unless I'm like confused about it. Okay. So double booking happens when they have non-empty intersection. So effectively this is inclusive but n-1, so that's a little bit awkward. I don't know, maybe it's fine. Anyway, for each call to return true if the event can be added, otherwise return first and do not return. Okay, so this seems pretty straightforward. Basically you have a list of events, and then you're trying to think whether there's an event in it, right? And actually this I know that there are a couple of solutions for this for sure. Okay, well, the really basic one is noting that the number of the test cases is 1,000. And to be honest, if this was a contest or something, and this is like a second problem or easy problem relatively, or like second problem, like a quote-unquote medium but relatively easy problem, I'll look at the n and I just do some n square algorithm where we just loop for everything twice, right? Sorry, we insert and we loop for everything once, and that's fine. That's pretty straightforward, and you can do that in like a minute, like just typing it out. There are a couple of other solutions. Some requires the one that I probably like is one that we is it no, it's scanline or sortline, yeah, scanline algorithm ish, but there is the one that or prefix sum, if you want to call it that. There's one about prefix sum as well, which is dynamic programming. But the key thing to noting is that so how do you do prefix sum? Well, you add 1 on the start range, and then you do a subtract 1 on the end range, and then now that you have this prefix sum, you just have to query everything in between. And of course, a naive implementation of a prefix sum is not going to cut it. But if you're being really slick and you do a binary index tree or a segment tree, then then that's how you would do it in n log n time. Or well, it's not n log n time. It's n log n log u time, where u is 10 to the 9th. Is that true? Well, I guess if you do it with binary index tree, that's true. But you could probably do it with a segment tree or something like that. Yeah. So there's some ways of doing it. There's also just binary search. You just put everything in. Same idea with prefix sum is that you just put. I mean, same-ish. They're all kind of related in a way because you're representing the same underlying data. But you can just do a binary search if. The thing to note there is that there are really only a couple of possibilities for segment. I mean, I think the tricky one is. Yeah, I mean, there are a couple of things you have to make sure you're binary searching on, but I think that should be okay. Or at least a binary index tree, and then Oh yeah, actually no. I mean, you could just. I was gonna do something even really fancy, but you can actually just just do two binary search, right? One on the end start point and one on the end point. And if there's any number in between or any endpoints in between, then so there are only a couple of scenarios, right? Either there's another endpoint in between your two numbers, or your current segment is entirely overlapped by or dominated by another event, which means that when you do a binary search, just look at two adjacent numbers or so forth. So yeah, so there are a lot of possibilities to play around this, because this is that kind of problem where there's just a lot of possibilities. So I gave you like 5 of them, maybe, I don't know, I didn't count, but try to upsolve it if you can and play around with it. Maybe not the n square one, because okay, you could spend a minute to play around with it. I think I'm just gonna do the binary search one, and then maybe we'll go over other people's solutions afterwards, because I think there are definitely a lot of solutions here. So yeah. So how do I want to do it? Okay, so let's just keep a sorted list. Yeah, I'm a big fan of sorted lists, but you know, make sure you know other ways of implementing around it. Otherwise, you know, you don't want to be in an interview where they're like, nope, you cannot use it, right? Actually, I'm having a little bit allergy thing. Everything's so itchy. I don't know if I ate something or just trees in general. I'm allergic to a lot of things. Who knows how these things work? Technology is weird. I don't know if you know this, but in New York, there's a New York Times article at some point recently, or maybe not that recently, a couple of years ago, where they mentioned that they changed all the sex of the trees to be, I think they changed it all to male. I could be wrong on that one, but anyway, they changed it to one of the sex, so that, because it's less messy. I forget which one it is. I think it's the male. It's the less messy one, where it's less smelly. But there's a lot more pollen, so that's why like everyone's just getting hit hard the last decade or so. Because when I was growing up, I was pretty fine. There was no issue here. But it is what it is. So yeah, so let's do 2 binary searches on this. I have to think about this a little bit with respect to whether this should be inclusive or bisect left or bisect right. I'm gonna make everything inclusive anyway, because this is just I don't like. So then you can be a little bit sloppier, I think maybe. Let's do start indexes here, and indexes you go self bisect left of n. If start index is equal to n index, that means that, okay, so now so if they're not in the same index, then we return false, because that means that literally there's an endpoint in between, right? So you don't want to add it, because if there's an endpoint in between, then, you know, if you have this point and there's an endpoint here, that means that by, you know, either it overlaps in some way, right? You could visualize it in your head, whatever. But okay. And so now if they are the same, then that means that the other possibility is that you're in between 2 endpoints. So, I think I have to keep track of, because there are another scenarios, right, where like I guess we only have to keep track of I think I got it, but it's just running through the scenarios in my head. Definitely try it a little bit at home. I was going to think about caring about each particular segment and whether that matters, but actually I think it doesn't. It just matters whether you're looking at the right endpoint or the left endpoint, or the start endpoint and endpoint of the previous segment. Because, for example, if you have a segment like, you know, that's for the purpose of you know, if you have 2 indices that are here, and then you have one that is to the right, or the one that appears afterwards, if the starting point is to the left, yeah, because by some pigeonhole E or force E kind of way, if the index are the same, then okay, so you look at two things, right? One is that the index, if it is the right index, then it's just to the right. Is that true? I mean, that part is true. Oh no, because I was going to say that there could be other overlaps, but in this case, the reason why that this could work is that there's an invariant in which nothing overlaps. Because if they're overlapping, then you have to check all these other segments. But here, the closest segment, because they're not overlapping, if it faces the other way. Yeah, another way of thinking about it. Okay, let me actually, I know that I talked a lot, and it's very confusing the way that I'm talking about it. So I'm going to just pull up Paint real quick. What I'm saying is that, okay, so let's say, we basically have a number line. We have points. Let's say our search is here, and then now we have to look at the two adjacent indexes, right? So I described these two the two adjacent endpoints as either a start endpoint or an end endpoint, but you can actually look at it the other way, right? If it's an end endpoint, that means that here this faces that way, or this one faces that way, depending on which one. And then if it's a start endpoint, then it faces that way, right? And because there are no overlaps, if this index is facing this way, if changing colors, hang on. If we're doing this way, that means that this line's endpoint is going to be going the other way somewhere, but it passes our point, because that's the definition of in between, right? And then in the same way, if we are here and it's facing left, meaning it's in an end endpoint, and it goes here, and it intersects with some other endpoint, but I guess it has to be this one actually, because as we said, there's no overlaps. So okay, so actually in that case, because there's a lot of things that are in a way forced because there are no overlaps, and because of that invariant, actually I was wrong about this drawing as well. This actually have to stop here, right? Because there's no overlaps. So that means that we just have to check for these things, and that also means that we only have to check for one endpoint, which is that the index is facing right, which it means that it's a start endpoint. Okay, so that's the only thing that we have to do. So yeah. So now, of course, we don't really do any. So now that just means that we have to track one thing more. Let's also double check real quick that this is in it, because there is a case where if this is length of this. Then so if this is in between, then that's good. Otherwise, if it's either all the way to the beginning or all the way into the end, then this is true. So let's actually return true in the other case. But here, let's say it's in between, so now we have to check the indexes. So we do start index. So let's just have two things, right? One is the x, which we don't care about because we know that it's smaller, and then let's just say we have a tag on whether this is the start endpoint. So it's start, say, as you go here, if it's start, return true. We actually didn't do this problem quite right, of course, or by we I mean me, because we have to insert stuff in the list, which we have not done. So okay, so actually let's actually change this to if it's not start, then we turn false. Otherwise we just do add here. And the way that I restructured this code so that I don't have to write the same thing twice, though depending on what you're doing, it may be a little bit tricky. So yeah, so now you just insert the start, which is insert true, and then also and also true. Sorry, and then force. And of course, we changed these to be inclusive. So hopefully this should be good. Let's give it a spin. Only one test cases, so I hope this is right. Tuple and int. Oh yeah. That should be sufficient. Add 11. Okay. I think I want to tuple up one element. I mean, I guess we can put a dummy element as a second element, but I think this should be okay. Nope. Int object is not iterable. Do I insert weird things? Okay, fine. Let's just do. I don't know if this would be sorted the right way. That's why I'm a little bit worried about doing this. I thought that you could do it with tuples of different lengths, but maybe I'm wrong. Oh, whoops. Maybe this is what I need. This is what I need. Okay, there we go. Syntax is very awkward. Apologize for that. The reason is because we have a second thing that we don't want to search by, and we want to get the first element no matter what anyway. And I forget whether, I mean, I think intuitively it would put false before true, but I didn't want to test that, and also it's a little bit awkward. So yeah, so this looks okay. I'm not confident about it because this test case is kind of crummy, but I am lazy, so I am lazier than I am not. I am lazier than I am unhappy. So let's give it a submit and see how it goes. Because after all, it is 3:28 a.m. Here in New York. Unfortunately, we do have a wrong answer, and at least it looks like it's a big case. 72 out of 148. Unfortunate though, still. But let's see. So that I could click on diff. So I returned. Probably later on as well, because these things tend to cascade, or maybe apparently not. But okay, so 1, 2, 3, 0 and 7 overlaps, but I return true. Dong dong dong. Why do I return true? Oh, because I searched for 6 here. And I know why. I think I know why this is the. Okay. Yeah, okay, I see why. Because now we search for 6 and inclusive, it finds a 6. So any overlaps is not good, but I did not check for that case. I was a little bit sloppy on this one. Okay, so then. And 6 is of course the end. No, this is a start point. Huh, that is awkward though. Wouldn't that... Because it is the start point. I do search for 6 and it finds 6. Huh. I mean, there are a couple of things to fix. That I'm just trying to think through it a little bit. So this returns the same index. Oh, because they return the same in... No. So it returns the same index. So it goes here. And then the start index should be 0. So it goes here. But then now, why would this be wrong? Dun, dun, dun. Alright, let's just... let's do some minor debugging. And I... Sometimes, even when I get something right, I will debug it because I'm not confident about it. But, oh, whoops. Okay, guess that's fair. Okay, so yeah, it does 23. 23 and 31, okay. 42 and 50, that's Gucci. 6 and 14. Okay, so that's good. This is also true. That's basically what I said, right? But why is the is start not right? Dun, dun. So this is 6 and true. So if this is, oh, maybe I just confused my logic a little bit. If it is the start, then it will return false. No, wait. Yeah, if it is the start, did I just have this logic wrong? Yeah, wow, whoops. I think I said the right things, but I confused myself at some point. Yeah, okay. I think my logic is just wrong in general, to be honest. I think I messed something up here. I think that's why I was very confused, and I just got, like I said, that's why I got lucky on the first one having that test case. But I definitely should have checked a little bit more. Okay, let me step back a second because I get confused easily. Clearly, so okay. Then when you do a bisect left, the number that you get is actually not the number on the left, it's the number on the right. So I messed up that one. I think that's where I confused myself. So if we look at the number to the right, and if the number to the right is the start, then that means that this is good. So if this is a start, we return true. But then that's how we, okay, so I think I did this by accident. I made two, so the funny thing is that I made two bugs that counteracted each other. But then now we're checking the one that's to the, so now this is the start. If this is a starting endpoint, we want to, I'm just trying to think whether it is good enough that we do a bisect right. I think it is actually, because then now the, but I could be wrong. I think I'm off by one on that one. Oh, no, I still have the same wrong answer. Huh. Okay, let's just. So it gives us the number that is. So okay, so bisect. Let me step back for a second. Okay, so the bisect left will get us the number that is bigger than this one or equal to this one. If it is equal to this number, then obviously it is not good. But whether it is start or not. Did we miss a case? I mean, how did I miss this case? I'm trying to think. Okay. And I think we're just, I'm just not handling off by ones very well. That's the short story, to be honest. Yeah, okay. I mean, I think we can just check it. Another case. I thought I didn't need this, but maybe we have some off by one issues that. Okay, so now it looks good, though obviously, given what we experienced, not as confident, but again, but I am still lazy though, so I am going to give us a admit. Get the wrong answer here. Okay, so let's take a look again at this one. So this one I have 99, 100, 45, 57. Huh. Did I mess this up? Why would this return false? Dong dong dong. So okay, so we're looking at the right side because by definition, I think I'm just confusing myself with the direction. Visualization is hard sometimes late at night. Okay, so if we do a binary search, we get the thing that's on it. Okay, that return false. So, or bigger. So assuming these two indexes are the same, then yeah, I think this needs to be bisect, right? I think this is a little bit awkward otherwise, but then this would never be true. So, oh no, I think I'm just being a little bit awkward. I think bisect right will get us to the next one. That is, for example, if it is 6, it gets us to next one, and if it's a start, then it is good. No, I think I just need to check for more cases. I think off by I'm okay, but this is just not even off by 1. So basically, this is saying that this searches. This gives us 0, 0 because we're inserting the beginning. This is Gucci. This is Gucci. We look at the first element that we're inserting before. It's going to be the 47, and it is the start. And because this is the start, this should be good. This should be good, right? Yeah, I gotta print it again. I get so confused right now. Though I think I have 2 other test cases, so maybe it's awkward. Okay. I think it's this one though, right? So 99 and force. Did I mess up? Why is 99 a oh, it's 99B. Oh, that's why. Because, I did forget about this case. So the case is that because we're now doing inclusive, now this is a point. And that means that here, it's going to give me true and false. So maybe it just by definition gave me a false for the start because it's taking to, like we said, it sorts by false first. Okay, how do I want to handle it? Well, I guess if they're equal, then they'll never overlap with anything. No, that's not true, because then the number can be like 90 to 100 or something, right? So we have to be able to support this case, but we just wanted to we want to sort this the other way, I guess. So I am very yucky today. My apologies. So I guess we just need to do SN instead so that it sorts the other way. And then is start is equal to SN. Maybe something like that. Evolution of bad code, I suppose. And I thought this was supposed to be pretty straightforward, but you see me struggle on this a little bit. Okay. Is this good again? Okay, this is good again. Let's give it a spin. Okay. Well, you've been hit with me half an hour. Give yourself some props for having a good attention span, or maybe just skip to the end. I don't know. Either way, give yourself props. Thanks for the support. I appreciate it. But yeah, so what is the complexity of this? It's going to be n log n, where n is 1,000. Maybe if I just did the 2 for loops, it would be less embarrassing. Because we do a couple of binary search, but constant number of binary search each, and each of them is going to be log n. So this is going to and also these 2 operations for it's not binary search, but a binary insertion, something like that. But yeah, so n log n is the total complexity, and that's all I have. let me know what you think about this problem. I think my visualization made sense. My implementation is kind of terrible though, and I had some weird edge case that I did not anticipate enough with respect to the 1 point case, I guess, with the inclusivity. But yeah, well, hope this was educational for you. Let's actually take a look at the solutions before I go. But I still hope it was educational for you though. Let's see what other. I mean, I think I mentioned a few, so yeah. I mean, we knew about before, so that's fine. Bands tree, that's kind of what we did. Yeah. Okay, yeah. So we basically did that, and that's the two ideas that they have. Oh well. Yeah. That's all I have for this one. I think I could have done. I think I tried a little bit too hard looking back, though. In that I try to make this like prefix something that which I generally like thinking about things in a prefix some kind of way because it comes in a lot more handy in different places. But I think what we looked at very briefly at the binary search tree solution is that if I just put the actual segment in the binary search tree, then I could have just binary search for the next one and then just see if it overlaps and then look at the previous element or something like that, see if that overlaps. And that would have saved me a lot more time. But and because when you're doing interviews and competitive especially, you want to keep it as stupid as possible, as simple as possible, because that means that you're not doing anything fancy, and it'll get you very far. Once it gets hard, it gets hard, but for the simple ones, keep it as simple and stupid as possible, because when you try to do things that are an overkill, you know, people are not that impressed. People just get I mean, people may be impressed if you get it right very quickly, but if you mess up, then people will be like, what is this person doing? Anyway, hope y'all have a good Thursday and the rest of the week. I'll see y'all later. See you tomorrow, hopefully. And happy lead coding, happy solving, and to good mental health. Bye bye.